So in this section, we're going to expand and factor algebraic expressions, and we're going to start with expanding. So we're going to use the multiplication property of distribution, and this will be very helpful for not only this class, but your next algebraic classes. So this should be pretty good. So we're going to start expanding algebraic expressions using the distributive property of multiplication. So they're using bar models to really help you out here, so let's make sure we use those. I'm not going to expect you to draw them, but to help explain. So we're going to expand, or use the distributive property of multiplication, 2 times r plus 8. So when you have parentheses like this, and you have a number outside of them with no operation, you don't see anything, it's just outside, it's known to be multiplication. So this means, basically, is what this says, 2 groups of r plus 8, which is what's inside of here. So if you use the bar model, you have one group of r and 8. We don't know what r is yet, it's just a variable. And we have another group of r and 8. So we have 2 groups of them. So why not put the like terms together? R and r, 8 and 8. So here you have r and r, 8 and 8. So we just try and shuffle these around, right? In fact, I can even draw it. And there you can kind of see, you just shuffle them around. All right, and so we have 2 groups of r, so 2 times r, and 2 groups of 8, or 2 times 8. So based on how you can see what's happening with the bar models, what you're doing here when you have expanding is you're saying 2 times r and then 2 times 8, which you can see here with the arrows that they have. All right, or 2 times r, which you see here, and 2 times 8, which is what you see here. So it gives you 2r and 16. And again, it means you have 2 terms and the coefficient is 2. And you can see from this kid, there's another way to think about it, which is what they kind of show on the bar model, that 2 times r plus 8 is 2 groups of r plus 8, which is 2 groups of r plus 8. We'll put the like terms together, r and r, 8 and 8, and then combine them. That's 2r, and 8 and 8 is 16. So the 2r plus 16, which is what you guys came up with, is the expanded form of 2 times r plus 8. And you know they're equivalent because you can just give a random number to r and see what happens. So let's actually do that. So we'll start off with, instead of 2r plus 16, we'll say 2 times 2 plus 16, which would be 4 plus 16. Oh, here we go. And that equals 20. Oh my gosh, can I actually write it? Yay. All right, let's do the other one. So we have 2 times 2 plus 8 in the parentheses. Yes, that is an 8. It becomes 10, so we have 2 times 10, which is 20. And if you're still not sure, try 6. And you'll see that both answers will become 28. So they're equivalent, they are the same. All right, this is the expanded, that's the normal form, and this right here is the expanded form. We're going to do the same exact thing here when we're going to expand 3 times k plus 6. That means 3 groups of k plus 6. So if as a bar model, see k plus 6. So here's one group, and then here's another group, and finally our third group. 3 groups of k plus 6. Then we can rearrange them, and we'll do that, so that all the k's are together, and all our 6's are together. And, well, what's the easy way of writing that? All these 3k's is simply 3k, and these 3 6's is 3 times 6, which becomes 18. How do you do this without a bar model? This is how you do it without a bar model, which is probably what you want to do. You don't want to draw this whole entire thing. You say, okay, I'm taking what's outside, I'm going to distribute it what's inside the parentheses, hence the distributive property of multiplication. That 3 times k is 3k, and 3 times 6 is 18. So 3k plus 18 is the expanded form of 3 times k plus 6, or 3 groups of k plus 6. All right, and this is him thinking what you guys just did in the bar model. Instead of giving you examples, this person's now stating that three groups of k plus 6 and the expanded form 3k plus 18 are equivalent expressions because they are equal for all values of k. So no matter what number you give in k, it will be equal. If you don't believe me, go ahead and try it with 2, 3, 4, and 5 and see if you ever get something different. So what I'm going to do is 1 and 2 for you guys, and then in Google Form you're going to do 3, 4, 5, and 6, and then a separate sheet of paper with 7 through 10. Okay, and I want to see not just yeses or nos, all right, but I want to see the work behind distributing. This is the main thing I'm looking for. If I just see yes or no, I'm going to say that's not good enough. Okay, I want to see the work. I know if you have actually watched the video, if you've done your work. If you just put yes or no, it's going to be pretty obvious who didn't watch the video, and you're busted. All right, here we go. For number 1, it says expand each expression. It's 3 groups of x plus 4. So it's 3 times x, which would be, oh my gosh, 3x. And we're going to keep the plus sign. And 3 times 4 is 12. Ooh, there we go. No. Number 2, 6 groups of 2x plus 3. So I can say 6 groups of 2x, or 6 times 2 is 12. And of course I keep the x, that's our variable. I keep the addition sign, it's not going to change. And then 6 times 3 is 18. Oh my goodness, there it is. All right, that's an 8. Go do Google Form, make sure you show all your work on a piece of paper for 7 through 10, and I'll see you tomorrow.